Hello, scientists. Thanks for tuning in. This video is about scientific theory and scientific law. Before I explain what theories and laws are, let's go over some examples of scientific theories and laws that you may have heard of before. Let's start with theories. Some examples are the theory of evolution, which was proposed by Charles Darwin in the 1800s, providing a possible explanation of how we have all of the different living organisms we have today. The Big Bang Theory, which is a possible explanation for how the universe began. Theories of the origin of the moon, which are some possible explanations for how the moon came to be. The theory of plate tectonics, which is a possible explanation for how certain landforms came to be and why we have earthquakes, because it is a theory that the Earth's hard outer shell is broken up into lots of large pieces called plates that slowly move over the hot liquid layer of Earth above the core. And cell theory, which is the theory that all living things are made up of cells, that they are the basic building block of all organisms, and that all cells come from other cells. You've probably heard of some scientific laws too. Some examples are the law of gravity, also known as Newton's law of universal gravitation, that states that every particle attracts every other particle in the universe with a force that depends on how much mass the particles have and the distance between them. You also know gravity as the pulling force that causes all things to fall toward Earth if you drop it. There's also the law of planetary motion, which states that all planets orbit around the sun in an elliptical shape. There's also Newton's three laws of motion, which each describe how objects move, and laws of thermodynamics, which describe things that we know about temperature and energy. Keep these theories and laws in mind as I explain what they are and the differences between them. Let's start by going over scientific law. A scientific law describes what scientists expect will happen every time under specific conditions. In other words, laws describe what happens in nature. Laws are different from theories because they do not include an explanation. Laws simply describe what happens, not why or how. That is what theories are for. Let's look at an example of a scientific law, the law of gravity, also known as Newton's law of universal gravitation. This law describes how objects in the universe attract other objects to each other. The more mass, or the heavier the objects are, the greater the pull on each other. The further apart they are from one another, the weaker the pull. Gravity is the force that pulls objects toward one another, including Earth pulling objects down onto it and keeping them here. The reason why we can't just jump up from Earth and fly away is because Earth's gravity pulls us down. The way we often describe gravity is by saying, what goes up must come down. Gravity is something we observe every day. When we throw a ball into the air, it always comes back down. Because humans have always experienced gravity, and it always works the same way, we expect everything to obey the laws of gravity. With the law of gravity and the mathematical formulas that come with it, we can calculate the gravitational pull between objects, as well as the acceleration of falling objects. This means we can calculate how quickly an object will fall if you drop it from a certain height. Now, remember that laws do not come with explanations. So the law of gravity does not explain why or how gravity does what it does. It simply describes what gravity does. The job of theories is to explain how or why things happen. Next, let's go over scientific theory. A scientific theory explains a wide range of observations and experimental results. The key is that a theory is an explanation of something, explaining what it is or how it works or how something came to be a certain way. Theories are also very well tested within the scientific community. This means that theories are not just random guesses by anyone and everyone. There are lots of observations and data to back it up, and lots of scientists have to agree in order to write these theories. But the thing is, science is also changing all the time. Humans have learned a lot of new scientific facts over the years, and they learn more all the time. Sometimes scientists may have a scientific theory based on the information they do have, but there may be a lot more that they don't know. As time goes on, new information is learned or new observations are made. Sometimes these new observations don't fit with a current theory. So if a theory can't explain new observations, then the old theory is thrown away and a new one is developed that takes the new observations into account. For example, astronomers a long time ago used to think that the Earth was the center of the universe and that everything revolved around Earth or everything traveled around Earth. Later, new evidence arose that proved that false and that the sun is actually the center of our solar system and all of the planets revolve around it. That's one example of a theory being thrown away in light of new evidence so that a new one can be written. Now, one thing that is commonly said is that theories can't be proven. Technically, this is true. Because it is difficult to prove that an explanation is guaranteed to be right. How can we know? When can we say that we've gathered enough evidence to be 100% sure that an explanation is the right one? The thing is, we can't. As I already mentioned, we gain new scientific knowledge all the time, and a theory may have to change when we learn new things. But until a theory is disproven with new evidence, it is the best explanation that we have. Remember, theories are not just random guesses. There is a lot of scientific data to support it, and a lot of scientists have to agree before it can become an official theory. Let's look at an example of scientific theory. Theories about the moon's origin. There are many theories of the moon's origin that attempt to explain where the moon came from or how it formed. Scientists take observations and evidence that we have about the moon and put it together to make a possible explanation of how the moon got here. There are lots of theories because the information we have could mean different things, and there isn't enough information to know for sure. The thing is, humans weren't there when the moon was formed, or at least no one observed it and wrote the information down. So we can't know for sure how it got here. Instead, scientists have come up with their best idea or guess of how it happened based on the evidence they have. What happens if new evidence is discovered that disproves one or all of the theories? Just like with all theories, if a theory is disproven, a new one will be written. So to summarize, what is the difference between scientific laws and scientific theories? Laws describe what happens in nature. Based on things that scientists have observed, they have come up with laws to describe exactly what will happen every single time in certain conditions. When this happens, this is the result. Now, theories describe how or why something happens in nature. Laws describe what happens, and theories explain how or why. Theories can also be used to explain things about the past, things that can't be observed happening anymore. Because they already happened and a scientist can't make observations about it, they have to use the information they do have to come up with a possible explanation.